Hello guys, you're welcome back to my channel, Fun with Physics. In today's lesson, we are going to look at density from Unit 8.8, part of our textbook, Complete Physics, Cambridge Secondary 1 by Helen. Now, before we move ahead, we need to have an idea, a clear picture of what density is all about. The word density is actually derived from dense, and when something is dense, it means we have a lot of stuff in it. Okay? Now look at the demonstration that we have on the picture here. Here we have a square and some dots. Okay? The dots here actually represented students. And the dots here too are representing students. In each of this square, which one can we consider to have more students? I believe this, isn't it? So which one would we consider to be dense, much more dense? That the population of the students are high or higher. That's this, isn't it? Okay. Now which one can we consider to have less space between each of the students? Still this, right? So we can say that this is denser than the other one, isn't it? Than the other one. Good. Now let's look at this. I want to look at the idea of density also, of how dense the two of these spaces are. Now look at this space here. We have a small square, here we have a large square, and we have 5 students here and 5 students here. Now which one can we consider to be more dense? What I mean is more students in a given space. I believe this, isn't it? So this one, because we have like 5 students in a small space, and here we have 5 students in a big space. And the space, the gap between each student is higher, too big, right? Like they're considering, they're having this social distancing thing. Get the idea? Okay, and this one, the gap between them is not too much, right? So this is considered to be dense because the space between them is not too much, and the entire region where they're staying is too small. Now, what is density in physics? Density in physics is the mass in a given volume, or in 1 unit volume. The mass in a given volume, or mass per unit volume. Okay? So how much matter do we have in a given space, or in 1 volume? That's the density, or that's density in physics. Okay, we can write density as using this letter equals to m over v. Alright? So where m stands for mass, v stands for volume. Okay? So m is measured in gram, v is measured in cubic centimeter. You can also measure m in kilogram, v in meter cube, as the case may be. There are several units anyway. And density is measured in gram per centimeter cube. Okay, now density tells us how much mass there is in a certain volume. We have a metal here, wood, and a plastic. Now you want to find out how much mass you have in this volume. Density will help you to do that. These blocks all have the same volume, but they have different densities. Now why do you think they will have different densities? Why do you think this one have a density more than this, and this have a density greater than this one? You have an idea? Remember I said density tells us how much mass you have in a given volume. So we have more mass here in this volume compared to this one, isn't it? right? And more mass in this plastic compared to this, right? Okay, now measuring the volume and mass of a liquid. The quantity of space an object occupies is its volume. That's what we mean by volume. The space you have in a given object. Okay, like this library has a whole lot of space, isn't it? So we can see it has a big volume compared to the class. The class have the space there is not that much. Now the unit of measurement for volume is milliliter or centimeter cube, or even meter cube, as the case may be. Now what tool can you use to find volume in a liquid? What tool? Can you remember the tool we use in the laboratory to find the volume of a liquid? Yeah, there are several tools, a lot of tools we can use, but the common one is a measuring cylinder. Okay. All right. Now, how to measure volume of a liquid in a measuring cylinder? Now, it's important that we know how to measure volume of a liquid, especially when we want to find out the density of the liquid. It's important that you know how to measure the volume. Okay, now from the left hand side here, you can see this guy the way he's looking at the screen. That his line of sight is directly in front of the scale mark of the meniscus, the lower part of the meniscus, this point. His line of sight is exactly in line with it. Okay, now this is actually done to avoid what is called parallax error. Now, parallax error is usually occur when you look at it at a different angle. Like you look at it from below, you have a low reading. You look at it from above, you have a high reading. Okay, so you must look at it straight. That's your line of sight must be in line with what you're reading, the scale mark you're reading, or the lower section of the meniscus. Okay. All right. So how do we measure mass? After measuring the volume of a liquid, now it's important that you get the mass of the liquid to be able to calculate the density of the liquid. So once we know the volume, we need to measure the mass. To measure the mass of the liquid, we find the mass of the container first. Okay, get the mass of an empty container that you're later going to put the liquid like this. The mass of this empty container is 120 gram. And you can put the liquid that you want to get the mass inside the empty container. Okay, make sure that none spills off, and then get the mass of the liquid plus the empty container, which is 520 gram here. Okay, so to get the mass of the liquid, you subtract 520 gram minus 120. That will give us 400 gram. So the mass of the liquid is 400 gram. After which you now calculate the density from mass over volume. So this is just an idea. Okay, it's not a specific density for any liquid, it's just an idea of density. Okay, now we can generally put the formula in the triangle to help us to be able to calculate other parameters. For instance, you can put your density, which is mass over volume, in this formula. Okay, you want to calculate density, you say mass over volume. You want to calculate volume, you say mass over density. And you want to calculate mass, just close it with your tongue and you say density times volume. Are we good? Right. Measure the volume and mass of regular solid when then calculate its density. Now, what do you do when you want to calculate the density of, let's say, a regular solid? Now, we previously looked at a case where we have to calculate density of a liquid. If you want to calculate density of a solid, a regular solid, all you need to do is to measure each of the sides, like what you have here, the width, the length, and the height, and then calculate the volume from length times width times height. Or for this, in this case, you can measure the radius and the height and apply the formula for volume, which is pi r squared times height, to get the volume of this solid. Okay, Now you can now get the mass by placing it in a balance. Okay, and read off. When you read off, you get the mass. After which you can calculate the volume, the density from the formula mass over volume. Okay. Now to measure to get the density of an irregular solid, we need to get the volume. An irregular solid is a solid without a fixed shape or a fixed dimension. Doesn't have a fixed shape. Now for you to get the density there, this is an example of an irregular solid, stool. Okay, for you to get density of an irregular solid, we need to carry out this procedure here. Okay, this is one procedure, this is another procedure. For a small solid, then for a big solid. For a big solid, we can use an Eureka can to demonstrate that to get the volume. Okay, but for a small solid, all we need to do is to put a volume, some quantity of water at any volume in a measuring cylinder, then gently place our irregular solid inside. Now the volume of the water is going to rise, then subtract the volume, the final volume of the liquid from the initial volume of the liquid. Okay. Now if you have a large solid, you can just simply put it in an Eureka can containing water at this level. Okay, the extra water is going to spill off to the flask you have here, flat bottom flask from which you can read off your volume. Okay. Now remember that you need to do this one first. You need to get the mass of the irregular solid. Okay, before you do the previous one. And why do you need to get the mass first before measuring the volume? Why do you need to get the mass first before getting the volume? Remember that we don't want an extra mass on this stone here, on this irregular solid. So for that reason, it must be dry. You must get the mass first before you put it in the liquid to find the volume by what you call the displacement method in the previous slide. What we call this the displacement method. Okay. All right. So we've actually seen how we can get the density of a regular solid and an irregular solid. Now the next step is to practice some question. Let's say you have, after carrying out your investigation, your practical, you need to solve, calculate, how do you do it. Now let's quickly go through the practice part of it. Okay, the block of a wood has a mass of 270 grams and the volume is 540 centimeter cube. What is the density? In this case, the density is mass over volume. Just substitute in the right order. 270 grams over 540, that will give us 0.5. Don't forget the unit, gram per centimeter cube, the combination of these units, okay? Gram/centimeter cube. Okay, now let's move to the next question without wasting time. Calculate the density of a metal block of volume 0.2 centimeter cube and mass 600 grams. Do we know how to do it? Let's follow the steps below to do it. Did you get the step? Notice that we must state our formula before solving. And our unit, final unit, is very important. Now the third one, so another question is calculate the mass of a block of wood of volume 0.05 meter cube and density this. In this case, we have to look for mass. Now remember how to put your formula in a triangle. The formula is density mass over volume. So you're going to create a triangle and put the mass at the top, density and volume below. So in this case, you want to calculate mass, you have to see becomes density times volume, right? Or you simply just make mass the subject of the formula, what you learned in mass, and then you solve, substitute at the right order, and get your final answer. Okay, calculate the volume of the liquid for 5 grams and density 900 grams. Okay, the same thing, we follow the same suit to to get our answer. In this case, you're looking for volume, make it the subject, and then calculate. Now this one is an interesting one. Let's see, let's solve it together. When a small stone is immersed into water inside the measuring cylinder, the level of the water increased from 20 to 27.5 milliliter. Calculate the density of the stone in gram per centimeter cube if its mass is 60 gram. Now you don't need to convert actually here, because 1 milliliter is the same thing as 1 centimeter cube, so you can use either units, okay? But what you do here is to get the mass of the liquid first in the measuring cylinder. So to get the volume of the liquid, get the volume of the liquid. Get the volume of the liquid first in the measuring cylinder, which is this 7.5 centimeter cube. Then we can now find the density using the mass, which is 60 gram, over the volume against the volume. So with that, we have the volume density of the stone to be 8 gram per centimeter cube. Are we good? So we have on and on. We keep going on and on and on here. Here the solid is actually cylindrical in form, so we can calculate the volume using the volume of a cylinder, which is pi r squared times height. Okay, and then get our density by substituting, and then solve to get the final answer. Okay, so we can keep going on and on and on like that. Alright, now you have this on the screen here. Please look at it. You can screenshot it. Let's see what you can do. Try it, attempt it on your own without looking at the answers, and compare your answers with this letter to see if you're correct. Now, if you have any question, you can also try this one too. So you try. If you have any question, comment on the comment section below, or if you have anything you feel I need to improve or work on, please comment on the comment section. Thank you.